Hello everyone, welcome to my channel. Today we will discuss some of the important questions of differential equations. So last day we have discussed some of the topics of differential equations. So there was four techniques we have discussed. So first technique was separation, second was substitution, third one was homogeneous, and the fourth one was linear differential equation. Now here we will solve some of the important problem of this chapter of differential equation. So let's start. So first question, so question number 1, sine inverse dy dx equals to x plus y, this one. So we have to find the differential equation of this one, sine inverse dy dx. Now how to find the differential equation of this one? So first of all, you can see there is a sine inverse. Now if sine inverse goes there, it will become dy dx equals to sine x plus y. Now this is sine x plus y. Now here separation is not possible, but here we can use substitution. X plus y we can substitute. So let x plus y equals to z. So here I am letting x plus y equals to z. Now if I differentiate with respect to x, that will become a1, and that will be dy dx equals to dz dx. So from here we can get the value of dy dx. So dy dx will be dz dx minus 1. So that will be the dy dx. Now this is suppose equation 1. Now we put the value of dy dx here in equation 1. So what will happen? So that will become like this, dz dx minus 1 equals to, now look at here, sine x plus y, and we have taken x plus y as z, so that will become sine z. So here it will be dz dx equals to 1 plus sine z, like this. Okay, so dz dx is coming 1 plus sine z. Now here we can use the process of separation. Now if you use the process of separation, what will happen? That will become dz by 1 plus sine z equals to dx, like this. Separation done. Now integration both side. Now while integrating, how to integrate this one, 1 by 1 plus sine z. Now there is 1 plus sine z, that means you have to multiply with 1 minus sine z with numerator and denominator. If it was 1 minus sine z, then you have to multiply with 1 plus sine z, both numerator and denominator. So here 1 plus sine z is given, so you have to multiply 1 minus sine z, numerator and denominator. That means 1 plus sine z into 1 minus sine z dz, like this, and here it is integration of dx. Now it will become like this, integration of 1 minus sine z, and look at the denominator. Denominator will become 1 minus sine square z dz equals to integration of dx. Now 1 minus sine z, that will be 1 minus sine z, and it will be 1 minus sine square, that means cos square z dz equals to integration of dx. Now this is 1 minus sine z by cos square z. Now simple thing, you have to just separate this one. So that will become like this, integration of 1 by cos square z minus sine z by cos square z dz, like this. Okay, and here it will be integration of dx. Now 1 by cos square means 1 by cos square will be sec square z minus, now sine z by cos square, so sine z by cos square can be written as sine z by cos z into 1 by cos z, that one, into dz, that dz equals to integration of dx. Now it will be integration of sec square z, this one will be sec square z minus sine by cos will be tan, 1 by cos will be sec, that means sec z into tan z dz equals to integration of dx. Now sec square z, what is the integration? Sec square z integration will be tan z, the integration of sec square z will be tan z minus, now sec x tan x, the integration will be sec z equals to integration of dx is x plus c. So that will be the answer. Now here what is z? You have to put the value of z. So z is here x plus y, that means tan x plus y minus sec x plus y equals to x plus c. So that will be the answer. Okay, so that is the way to solve it. So any one technique you have to use. You have to check which one we can use here. So here we can see separation is not possible, so here you have used the technique, that one, substitution, x plus y equals to z. Okay, now next one, question number 2. We will move to question number 2. So next question is given like this. Question number 2 here, log, so question number 2, look at here, log dy dx, it is given log dy dx equals to 2x minus 3y. Now how to solve this one? Log dy dx equals to 2x minus 3y. Now there is a log. Now since there is a log, what is the base here? If base is not given, that means you have to take the base as e. Now here you have to use the property of log. What is the property of log? If I want to remove a log, so what to do? Suppose this is given, suppose for example there is a, base x and b. Now suppose I have to remove the log. How to remove it? It will become like this, a equals to that one, x to the power b. So that is the property of log. Okay, log of a base x equals to b, then it can be written as a equals to x to the power b, like this. So here also you can see here dy dx. What will be dy dx? So dy dx will be e to the power this one. Okay, that means e to the power 2x minus 3y. So now here you can see dy dx, it can be written as e to the power 2x by e to the power 3y. Now this one, which technique will use here? Now you can see it is very easy that we can just separate this one. That means dy will be multiplied with e to the power 3y. So if you separate this one, that will become e to the power 3y dy equals to e to the power 2x dx. Only separation will be easy here. Okay, so here we just separate this one. Now integrating both side. Now if I integrate both side, what will be the integration of e to the power 3y? So you know integration of e to the power something is e to the power 3y by 3 equals to e to the power 2x. Now it will be e to the power 2x by 2 plus c. So that will be the answer. So here the answer will be this one, e to the power 3y by 3 equals to e to the power 2x by 2 plus c. Okay, so here we have used the separation. Now next one, we'll move to question number 3. So here in this one we will only solve some problems of differential equation, important problems of differential equation. Okay, that can be asked or that has been asked in the previous board exams. So question number 3. So question number 3 is like this. It is given, this is very important one. Okay, this question is very important one. 1 plus y square, very interesting problem. 1 plus y square dx plus x minus e to the power minus tan inverse y dy equals to 0. Okay, this one is given, 1 plus y square dx, x minus e to the power minus tan inverse y dy equals to 0. Okay, like this. Now what to do now? First here what we need to do is that you have to, from this we have to find dy dx. Somehow we have to find dy dx. Now how to find? 1 plus y square dx. Now if that one goes there, it will become like this, minus x minus e to the power minus tan inverse y dy, like this. Okay, e to the power minus tan inverse y dy. Now if dx goes there and this one comes here, what will happen? That will come like this, 1 plus y square divided by x minus e to the power minus tan inverse y, like this, and it will be minus dy dx. Okay, now look at it properly. Now this one separation is not possible. Okay, so just reciprocal this one, just reciprocal. I'm just doing the reciprocal of this one. That means x minus e to the power minus tan inverse y divided by 1 plus y square, and here it is minus dx dy. Okay, it will look like this, minus dx dy. Now next, if I this minus, if I multiply here, it will become, if I multiply minus both side, that will become like this. I am multiplying minus both side, that will become plus. Okay, now separate means this, separating by this one, x by 1 plus y square minus e to the power minus tan inverse y by 1 plus y square equals to dx dy, like this. Now if minus is multiplied, that will become minus x by 1 plus y square, and the minus minus will be plus e to the power minus tan inverse y by 1 plus y square equals to dx dy, like this. Okay, now if this minus, now this minus x by 1 plus y square will go there. Okay, go there, that means it will become dx dy plus dx dy plus x by 1 plus y square, 1 plus y square equals to e to the power minus tan inverse y by 1 plus y square, like this. Okay, now look at properly. Now which this expression, look at the expression properly. What type of expression this one? This one is similar as this expression, linear differential equation in x. Look, dx dy plus px equals to q. Now this expression is similar as this. Okay, so now from here we can guess what is the p here. Now if I look properly, if I compare it properly, what will my p? My p will be 1 by 1 plus y square. So p will be here 1 by 1 plus y square. So this is the p. Now if you got the p, you have to find integrating factor. Now what is the integrating factor? E to the power 1 by integration 1 by 1 plus y square dy. Now what is the integration of this one? That will be tan inverse y. 1 by 1 plus y square, the integration is tan inverse y. So this is the integration. Okay, now suppose this is equation number 1. So integrate, we got the integrating factor. So what is the next step? You have to multiply the equation with the integrating factor. So now multiplying 1, okay, multiplying 1 with integrating factor. Okay, with integrating factor, that means the if. So you have to multiply this one, so that will become like this, e to the power tan inverse of y bracket dx dy plus x by 1 plus y square, okay, equals to e to the power tan inverse y into e to the power minus tan inverse of y by, this one will be 1 plus y square, that will be 1 plus y square. Okay, like this. Done. Now so first you have to find the integrating factor. After getting the integrating factor, you have to multiply the integrating factor with the equation. Now what is the next step? The left hand side will become like this. Okay, now d dy, since here you can see this is d dy. Now here what you need to write, this is a linear equation in x, that means here it will be a x into the integrating factor. Now this is the integrating factor, e to the power tan inverse y, okay, equals to, now if I multiply these two, what will happen? The power will be added, that means tan inverse y minus tan inverse y, that will become e to the power 0. E to the power 0 is here 1, so 1 by 1 plus y square, like this. Now if dy goes there, that will become dx e to the power tan inverse y equals to dy by 1 plus y square. Now integrate both side. Now integrate, if I integrate both side, what will happen? Look, this is d of something, the integration will be this one only, that means x e to the power tan inverse y, the left hand side will be this one, equals to, now what will be the right hand side? 1 by 1 plus y square, that means that will be tan inverse of y plus c. So that will be the answer. Okay, so the left hand side is here x e to the power tan inverse y, and the right hand side here would be tan inverse of y plus c. So that will be the answer. So here you have used the linear differential equation. Now next we'll move the next one. Now for the next one, the question is given like this. Okay, question number 4. Now we'll move to question number 4. Now what is question number 4 here? Question number 4. Now in question number 4, it look like this. X cos y by x into y plus y dx plus x dy equals to y sin y by x into x dy minus y dx, like this. Okay, now if I look properly here, now how to solve this one? Now if I look properly here, you can see there is y by x, here also it is y by x. So we have to target, somehow you have to target y by x here. Now how to target here? So first of all, so find properly here y dx. Now if this term goes there, what will happen? It will become y dx plus x dy equals to y sin y by x by x cos y by x, like this. And here it is x dy minus y dx. Okay, so I'm just targeting y by x here. Okay, now here y by x, now here you can see this is sine by cos. Now what is sine by cos? That means it will be tan. So it will be y dx plus x dy equals to y dx plus x dy equals to y by x tan y by x, that is y by x tan y by x into that will be x dy minus y dx, x dy minus y dx. Now look at this, we can see here somehow there is a y by x, we can get y by x here. So first we are letting y by x equals to z. Suppose here y by x, I am letting y by x equals to z. So here you have used the substitution y by x equals to z. Why y by x? Because here you can see there is a y by x, there is also a y by x. Now what will be the next step? Now in the next step, what will you do is that find, so here from here you can see y equals to x into z. Now if I differentiate this one, what will happen? With respect to x, that will be dy dx equals to 1 into z plus x into dz dx. This is the dy dx. Now look at here, here it is dx dy. So first of all what we need to do is that we have to make it to dy dx. Now how to make it dy dx? So here you can see dx dy dx dy, like this. So you have to divide dx. Okay, so suppose I am divided by dx, so what will happen? Y plus, it will become y plus divided by dx. Okay, so that will become y plus x dy dx. It will become x dy dx, like this. Okay, equals to, now what is y by x? Y by x is here z, so that will become z tan z, like this, z tan z. Now here again divided by dx, that means it will become x dy dx minus, it is become x dy dx minus, if I divided by dx, that will become y. Okay, that means we have divided both sides by dy dx. Now both side you can divide by x. If I divided by x, what will happen? It will become y by x plus dy dx. Okay, I'm dividing by x, z tan z dividing by x, this will become dy dx minus y by x. Now put the values. Now what is the value of y by x? The value is here z. plus now dy dx. What is the value of dy dx? This one, z plus x dz dx, z plus x dz dx equals to now z tan z into again dy dx. That means here you can see z plus x dz dx, z plus x dz dx minus y by x, again that is z. So you can see z and z cancel out and it is coming 2z plus x dz dx equals to xz tan z, like this. Okay, so it is coming like this. Now if 2z goes there, what will happen? Now it will become like this, x, it is coming like this, x dz dx. Okay, so it is coming x dz dx minus equals to x tan z, x z tan z minus this one is coming 2z. Okay, this one is coming like this, 2z. Now if I divide it by, now look at this, this is the equation is coming. Now from here you can see, if I divided both side by x, that will become dz dx equals to z tan z minus 2z by x, like this. Okay, 2z by x. Now from here we have to solve this one. Okay, now from there if I solve this one, what will happen? Now this is 2z by x. Now if 2z by x goes there, it will be dz dx plus 2z by x. Here it is tan z. So this one is coming. Now from here you can see z, if I z is come here, nothing can be done. Look properly here, x tan z. So it is coming like this, y by x equals to z. So here y equals to x z. So if differentiate z plus x dz dx, now if I divided by x, that will come like this, and y by x is here, y by x is here z. Okay, so here it is coming z plus, and dy dx is here, dy dx z plus x dz dx. Now it is z tan z, x dy dx is z plus x tan z, z cancel out, so that means xz. Okay, there is some mistake is there, so that is xz tan z dz dx, like this. Okay, so it will look like this, xz tan z dz dx. Now here there are two dz dx. Okay, now if it goes there, it will become like this, 2z equals to, okay, 2z equals to, it will become like this, xz tan z dz dx, okay, minus, so it is coming like this, x dz dx. Okay, x dz dx. Now from here we can take, what we can take, x dz dx. We can take x dz dx common here. So what will be the remaining term? Z tan z minus 1. Okay, so it is the remaining term, 2z here. Now it is easy. That means you have to use here separation. So here it will be like this, x will go there, that will become dx by x, and here it will be dz z tan z minus 1 by 2z. Okay, now integrating both sides, that is 1 by x dx. Now here if I separate this one, z tan z by 2z, like this. Okay, z tan z by 2z, and here it will be 1 by 2z dz, like this. Now what is the integration of 1 by x? The integration of 1 by x is here, log mod x equals to, here the integration is z by z, cancel out, that means half, and integration of log tan z will be log mod sec z, like this. Okay, and minus 1 by 2 1 by z, half z. Okay, half 1 by z means log mod z here. Okay, and here the constant, we can take the constant at half c, like this, half c. Now 2 will be multiplied here, that means 2 log, we can take it as log c also, half log c, that means 2 log mod x, here half log z. Now what is my z? Here you can see z we have taken as y by x. Okay, so here you have taken z equals to y by x, so z equals to y by x. So that means here sec y by x, like this, minus half, so half goes there, that means log sec x by y by x, and here it will be log mod y by x. Okay, now just simplification, so that will be log x square, and here since this is a minus, that means there will be a division, that means sec y by x and divided by y by x. So from here we can write x square equals to what? X square equals to sec y by x, that will become like this, x by y sec y by x. Okay, sec y by x. Now here x and x will be cancelled, so x y equals to sec y by x. Now there is a constant, I think, yes, there was a constant term also, so that will be half, that was a log c, that means here it will be c into this one. Okay, so one constant term will be there, so it will be c, like this, 1 by c sec y by x. So that will be the answer. Okay, at the end that will be the differential equation. Okay, so this is a very good problem. So first of all, again we'll recap this one, how to solve. So first of all, you can see it is given x cos y by x, y dx, x dy, y sin y by x, x dy minus y dx, like this. Okay, so first of all, you can see y by x, that's why we have taken y by x here as z. Now we have found dy dx, now dy dx is here, z plus x dz dx. Now put the value here, if I put the value here and do the substitution, it will look like this. Okay, at the end it will look like this, and 2z x dz dx, z tan z minus 1. Now do the LCM. Now here we have to separate. Now here you can see there is a separation, so that will be dx by x, and it will be dz z tan z minus 1 by 2z. Now again separation and integrate that one, and that will be the answer. So that will be my answer. Okay, so this is the way to solve this. Now here one thing is there, plus log c. Okay, so there is a plus log c, plus means there is a multiplication, so c here will be multiplied. Okay, c here will be multiplied, so here it will be a c will be there, so c sec y by x, so that will be the correct answer. So this is the way to solve this question. Now we'll move to question number 5, next question, that is question number 5. So question number 5, so the question is given like this, dy dx equals to e to the power x plus y plus x square e to the power y. Now look at here, first if the differential equation is given, first look at properly what we can do here. From this, what is the next step we can do? So here you can see dy dx, now e to the power x plus y, that can be written as e to the power x into e to the power y, plus now next, now here it is x square e to the power y, like this. Okay, now from these two, what we can do is that e to the power y can be taken, is a common element here, so e to the power y, so that is coming e to the power x plus x square, and here it is dy dx. Now it is very easy. Is that, so dy, now just use the separation, that means dy will contain y term and dx will contain x term, so that will become like this, dy by e to the power y equals to, now equals to on the right hand side it is e to the power x plus x square dx. So that will become like this, e to the power minus y dy integration, and that is coming e to the power x plus x square dx. So e to the power minus y, the integration will be e to the power minus y and minus, and here it will be e to the power x plus x cube by 3 plus c. Now this one is very easy. Now c is a integrating constant like this. Okay, so that one was very easy one, just we have to do that separation. Okay, now next one, now question number 6, we'll do question number 6 now. So what is the question number 6? So question number 6 is given like this, 1 minus x square dy dx. It is given 1 minus x square dy dx plus xy equals to ax. Okay, like this, 1 minus x square dy dx plus xy equals to ax, like this. Now how to solve this one? Now for this one, again, what you can see from here, 1 minus x square dy dx plus xy equals to ax is like this. Now 1 minus x square, first find dy dx. How to find dy dx? 1 minus x square is there, so first divide both sides by 1 minus x square. So it will look like this, 1 dy dx plus x by 1 minus x square into y equals to ax by 1 minus x square. Now you can see this is a linear differential equation. Okay, dy dx plus py equals to q type. So that means the value of p, what is the value of p? The value of p is here 1x by 1 minus x square. Okay, so that will be the value of p. Now from this you have to first find the integrating factor. Now what is the integrating factor? E to the power p dx. Now what is the p here? X by 1 minus x square. The p is here x by 1 minus x square dx. Now how to find the integration of this one? To find the integration of this one, first find the derivative of this one. Now what is the derivative of this one? The derivative of 1 is 0 and derivative of x square is minus 2x. That will be minus x square. So the derivative will be minus 2x. That means multiply minus 2. Here you have to divide minus 2 dx. Now here what will happen? E to the power minus half. Now look at what will be the integration of this one. You can see the derivative of the denominator is coming the numerator. Okay, derivative of the denominator is coming the numerator. That means what will be the integration? The integration will be log mod denominator. So that was the formula. Now that means e to the power, that will become e to the power log 1 minus x square whole to the power minus half, and e and log is together, that means 1 minus x square whole to the power minus 1 minus half, that means 1 by root over of 1 minus x square. So that will be the integrating factor. Done. So this is the step first one. Okay, now take this equation as equation 1. Now what we need to do is that integrating factor, you got the integrating factor, you have to multiply the both side with the integrating factor. Okay, so both side integrating factor. Then what is the next step? We have to write the LHS, left hand side, like this, d dx. This is integrating linear equation, linear differential equation in y. So y into the integrating factor 1 minus x square. Directly just write it down. Okay, left hand side will be that d dx. This is a linear differential equation in y. So y into the integrating factor. Done. And on the right hand side, look at the right hand side. What is the right hand side? Right hand side is this one, ax by this one. That will be multiplied with the integrating factor. So ax by 1 minus x square. This one is the right hand side. So that will be multiplied with the integrating factors. What is the integrating factor? 1 by root over 1 minus x square. So that will be d y by root over of 1 minus x square, and here it is ax by 1 minus x square whole to the power half and 1, that is 3 by 2 dx, like this. Okay, now integrate both side. Now if I integrate both side, what will happen? The left hand side will become like this, y by root over of 1 minus x square equals to, now a will go there and it will become like this, x by 1 minus x square whole to the power 3 by 2 dx, like this. Now how to solve this integration? Okay, now this integration is very easy. How to solve 1 minus x square whole to the power 3 by 2? So here we have to take 1 minus x square as z square. Now differentiate this one, that will be minus 2x dx, that is 2z dz. So that will be dx equals to z by minus x dz, like this. Now just put the value here, so that will become y by root over of 1 minus x square equals to a into integration of x by 1 minus x square whole to the power 3 by 2. 1 minus x square means z square to the power 3 by 2 into dx. Now what is the dx here? Z by minus x dz. So it is written like this, z by minus x dz. Now if I see here, x and x cancel out and 2 cancel out, so that become minus a integration of z by z cube dz, like this. So it will become a minus a integration of z to the power minus 2 dz, and here it is y by root over of 1 minus x square. Now z to the power minus 2, again you know what to do it. So in y by 1 minus x square minus a into, so that will be z to the power minus 2, that means z to the power minus 2 plus 1, that is minus 1 by minus 1 plus c. So that will be y by root over 1 minus x square equals to a by z. Now what is the value of z? So here you can see what is the value of z. The value of z here, root over of 1 minus x square. So here it will be 1 minus x square plus c. So y will be here, if it goes there, it will become a plus c into root over 1 minus x square. Okay, like this we have to solve. Okay, so this is the way to solve. So for differential equation, the only thing is matter is that there are 4 techniques. You should know 4 techniques are there. One technique is called separation. Next one is called the same thing, separation, substitution, then homogeneous, and last one is the linear differential equation. Linear differential equation is very much important. Okay, very much important topic, this one. So here you can, now this one, the last question, you have used linear differential equation. So this one is very much important, linear differential equation. So those are the ways to solve linear differential equations and many differential equations. Okay, so this is the topic of differential equation. In the next classes we will do another problems of differential equation. Okay, thank you for today.